Welcome. Good morning, good afternoon, I don't know what time of day it may be for you, but here we go with areas of regular polygons. Today, the learner will devise methods to find the areas of regular polygons. All right, so how do we do that? Let's start off with this. So, on the areas of regular polygons, we need to know certain things. First off, what is a regular polygon? Okay, a polygon is a multi-sided figure. Pentagons are polygons. Hexagons, octagons, heptagons. Those are all polygons. Now, irregular means that all the sides are the same. So keep that in mind because there's an easy way to find the perimeter on that. Now, we have an apithum. An apithum is the distance from the center of the polygon to any side from the center to any side. The radius is the distance from the center to a vertex. So, this right here that you see, this little line drawn here, that's, let me write, you lousy pen, that's the apithum. This line right here, that's the radius, okay? Where will those two be important? Well, we'll see. We use the radius more to help us find the apithum if we don't have the apithum. Now, keep in mind, the area for this, the formula for the area is just this formula right here, 1/2 the apithum times the perimeter. Okay, so like if you look at like say the first one, and this is what on the test I'll probably try to be like this, where I give you the apithum and a side, but I'll show you how you can find the apithum. Okay, depends on which class you're in. All right, so here you can see here's a side, here's another number. Okay, so we got these two numbers. Now one of these, again, we need the apithum and the perimeter. Okay, so the apithum, again, is the distance from the center straight to the side, so it's 7. The perimeter, well, there's one side at 24.2. They're all regular, so if I say 24.2 times 3, then that would give me the perimeter of the rectangle, which in this case would be 72.6. Okay, so if I take the apithum times the perimeter and multiply those two, don't forget the half, so the area would be equal to 1/2 7 times the 72.6. Ooh, I should have given myself more space to write. That would give me an answer of 254.1 square feet. Okay, and that would do it. That would be it. So again, here you can see the apithum is 16. The perimeter would be 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. So 13.3 times 8, which would be 106.4. So there was the apithum. Apithum was 16. The perimeter was 106.4. And the area is equal to 1/2 of those two numbers, and that would give you the area. Fairly simple, should be easy, and this would give you an answer of 851.2 centimeters squared. Okay, so again, it's up to you like how you see those. Now, steps to find the apithum and or side length. Okay, so those are when I give you the apithum. What happens when you have to find it? Now, I'll give you some shortcuts on that, and you'll see some shortcuts that will hopefully make some of this a little bit easier, but it'll be more for some of the others, and I'll show you what I mean. Please take notice what they do to help you find the steps. Create a right triangle by drawing the apithum and the radius. Find the measure of the interior angle where the radius intersects the vertex. You can use that whole angle sums formula, divide by n, then by 2, and I'll show you what they mean by that in a second. And then use special right triangles or trigonometry. That's where things get a little, say, interesting. Okay, so actually, let's do it this way. If you follow their steps, what they're saying is, like on number 3, I would make a little triangle, right triangle right there. Okay, I know one leg is 5. I know I need to find this length here, this little x, and I can kind of go from there. But I only have one side. So I need to find an angle measure. Now, if I take the number of sides here, if I do this, this is 1, 2, 3, 4, 5, 6. This is a hexagon. So if I say the 6 minus 2 times 180 divided by... I got confused for a second, but let me go back here real quick. This formula right here, says times. Okay, so I wanted to make sure that was correct because the one I was seeing said something else. Okay, so following that formula right there, notice it says then divide by n. So, okay, back here. If I say this divided by 6 like this, that gives me 120. That tells me like an angle here is 120 degrees. I divide that by 2. So every time I'm going to divide by 2, that would give me an angle here. So this angle right here is 60 degrees. Okay, so that means I'm dealing with a 30, 60, 90 triangle. Okay, so if you have a 30, 60, 90 triangle, you need to remember that's the one where we did like something like this, and it was x square root of 3 and 2x. Okay, so you got to determine which side do you have. And this 5 is this x squared of 3 bit, which means if I want to find this little length right here, I need to divide by the square root of 3. So if I divide 5 by the square root of 3, so if you have this one right here, and this is a hexagon, and so I'm giving you a hint here. If you have a hexagon, if you divide by the square root of 3, and this is something I would make sure of, that will give you half of a side. Okay? So if you divide 5 by the square root of 3, you should get about 2.89. Okay? Then, of course, if you wanted to, you double that. So you would get 5.78 approximately. That would give you a whole side. Okay? So if you say the perimeter then is 6 times that 5.78, you get that would be about 34.68. And then you could say the area is equal to 1/2 5, that's the apithum, times the 34.68. And that would give you an area of 86.7 square meters. Okay? So again, keep in mind that if you in this case, it's very important to make sure you note what you have. Apithum. And then and this works with a hexagon every time. This is the ones I like to do. If I give you the apithum, use a hexagon to help you find a side. You divide by the square root of 3, boom, that will give you half a side, but you got to multiply it to get the whole side, and then you can multiply by 6 to get the perimeter. Keep in mind, I would make sure I had this in front of me or whatever to help me during the test. Not that I'm saying that, your formula sheet. All right, so let's look at another one. Try doing this one for all the hexagons, but I'll come back to this. How do I make those different? Actually, I'm going to jump around. Okay, so here's another hexagon. But this time, they give you a side. So I can easily find the perimeter. I can easily find the perimeter by saying 6 times 22 and get 132. What I'm missing is the apithum. So how do I find that? Well, keep in mind if this is 22, and I make my little triangle, cut it in half, now this is 11, and I still need this bit. Every hexagon becomes a 30, 60, 90. Okay? This time, I'm saying I've got this part. Okay? So if you go back to here and look at that, I'm saying I've got this. I need this. The square root of 3 part is always the apithum. So now if I say 11 times the square root of 3, I will get the apithum. Keep in mind if they gave you this one, that would be this one right here, and you would divide by 2 to get to here, and then you could multiply by the square root of 3 to get to here. Okay, so I'm trying to give you some ideas. Anyways, this would be 11 square root of 3, which is about, let's see, what is 11 square root of 3? 11 square root of 3 is about 19.05. Okay, so now I can say the area is equal to 1/2 19.05 times 132. What? What? So, if I type that in, times, oops, I did double times. Didn't mean to do that. Double time, let's go! Times 132, you get 1,257.3. So you kind of get the idea. Now, let's go over to, say, some of the others. And I would try doing this with all those. But let's look at another one. Okay, so this one should be an equilateral triangle. So I could easily find out that this is 60 degrees. That means if I draw this little bit right here, that's a 30 degrees. So that's 30 degrees right there. Okay, then that means, again, I have another 30, 60, 90 triangle. But this 18 is over here. That means this would be 18 square root of 3. And this would be 36. That would be times 2. So here's the 36 times 2. But this would be 18 square root of 3. This right here. Okay? So, if that is the case, this little bit right here, I'm going to say is x. 18 square root of 3. Let me write square root of 3. Square root of 3. I can write square root of 3. Yay, square root of 3. Alright, I get 31.18. Okay, keep in mind, whenever you get this little bit here that's on the side of a regular polygon, you need to double it. Okay, because then that covers the whole thing. So, times 2, I get 62.35. Okay, so 62.35. I did that by multiplying by 2. Right. Okay. And then, okay, so I have to find the perimeter, because again, you got to go all the way around. So multiplied by 3, which gave me 187.06. The area would be half of 18 times the 187.06. And that would give you the area, which would be times 18 times this, 1,683.55, approximately. Okay, give or take a few decimal points. That's probably one where I would give you, say, some leeway there. Okay, so again, my idea is I would probably give you the apithum like you see on problems 1 and 2. But I'm trying to show you some of these other ones. So let me show you one of the ones that would be slightly more difficult. And kind of go from there. And then on this one, do as many of these problems as you can. You do not need to worry about doing the shaded ones, but do as many problems as you can. And we'll see what we take in. But I want to see you try to do every hexagon problem, and I'll rewrite this, and every one of them where they give you the apithum and the perimeter. So I'll mention to you which ones they want, or I will give you the apithum and perimeter for a few of these. Alright, so I'm going to go through this one completely. So here, okay, if I do the 5 minus 2, because this is a pentagon, times the 180, divided by 5, I get 108 degrees. Okay, so that means, again, this is 108 degrees. Divide that by 2, you get 54 degrees. So if I draw a little triangle like this, that means this is 54 degrees right here. Okay, so if you look at that triangle, I'll draw that here. And I'll put here 54. Here's 10. Here's 54 degrees. That means now I would have to use tangent to help me find this little length right here. Because this, again, is opposite and adjacent. So if I say tangent of 54 degrees, that would equal the opposite 10 over x. Which means I now actually have to say, to find x, I have to say 10 divided by tangent 54. Which would be equal to 7.27. Okay, so that means this right here is 7.27. If I double that, I get 14.53. So this side here is 14.53. Multiply that by 5 for the perimeter. So the perimeter like this. 14.53 times 5 gives me 72.65. Now I have everything I need. Half of the apothem, which is 10, times the perimeter, which is 72.65, and then that would give you the answer, which in this case would be 363.25. Okay, so for those of you in my other classes, like my pre-AP, y'all can maybe try to work those out. Again, how you have access to your calculators. But my main thing is, okay, is this hexagon? Can you work hexagon and help yourself find that perimeter? Test-wise, I'll probably give you the apothem and the perimeter like I did on or apothem and a side, you find the perimeter like I did on problems 1 and 2. So, let's do that. So there are your notes, all these problems I did. But I do want you to do, so I want you to do these problems 9 through 14 and 1 through 6 on your own. Now, on all these, I will go ahead and give you the apothem and the sides, although in some of them they give you either the apothem or the side, but I'm going to give them to you all. And then use those to help you figure out those formulas. So I expect to see these completed for full credit. All right, so let me go ahead and give those to you. Okay, so you can see here, you may want to pause this, but here's the apothems, here are the sides for these problems. Again, you're using the formula area is equal to 1/2 the apothem times the perimeter. You need to find the perimeters using these sides right here, okay? So if you have any questions, feel free to let me know, but before you turn this in, make sure you have these problems done. Anyways, that is it for today, guys. Thank you so much for your time. Hope everything's going well. Take care.